Hey mathematicians, Caitlin Henderson here with the Unit 8 Lesson 3 video on partitioning a segment, and specifically we are working with line segments. So let's get started in the lesson. Starting out in the text, there are two ways that we are going to be partitioning segments. In one way, they talk about a fraction, and in another way, what they are talking about more of a traditional ratio. So first, let's talk about fractions. Now, we have this line segment here. It's starting at the point 0, 0, and it's ending at the point 4, 0. And let's say that we are asked to partition this so that we have a point 3/4 of the way down our line. Okay, 3/4 of the way down our line. What that means is we need to take our line segment and partition it so that there are 4 parts to it. Okay, there's 4 total parts. Basically 4 little mini segments on our line segment. And then our point is going to be located on after the third segment. So here you can see we have a very nicely lined or segmented line here where we can draw a line at each one of these kind of like whole values, and it creates us these 4 little segments. Now, when I teach this in middle school, I like to think of these and I share with my kids that these are kind of like maybe like the segments in like a Hershey's chocolate bar, right? We've split these up so that there's 4 of these little segments. If this is a Hershey's bar, we could break them off and create 4 little segments of chocolate in our whole segment. So our whole segment in this case is 4 pieces, and we want to partition it or draw a point at which we maybe have eaten 3 of those pieces. So that means that we have our first piece here, our second piece, and then our third piece. That is where we are going to draw our point that is going to denote 3/4 of the way down our line segment. Like I said, I like to think of these as I have eaten 3/4 of my chocolate bar. And so I've eaten the first one, the second one, the third one, and then this is where the start is for my last little segment. But like I mentioned, this is 3/4 of the way down our line segment. We could kind of do the same thing. Let's say we wanted 3/8. 3/8 of a line segment. If I were to do 3/8 of a line segment, I would need to partition my line segment here so that there's 8 pieces. Well, I know that 8 and 4, 8 has 4 in it. So I can start with 4 and then I can split it in half again to get my 8 little even. They need to be even segments. So see there, got 8 little even segments, and then I can just count. If I want my point located 3/8 of the way, I'm going to jump 1, 2, and 3 down, and so my point would be located here. And if I were asked what was the location of my point, then I could look here and say that X is located at 1, 2, we're halfway in between it, so 1.5. And my Y is located here at 0 because we are on the X-axis. And I could even go back, my last one here, right, was at this 3/4 right here. I could go back, and if I were asked what the location of that one was, then I would do the same thing. I'm located at X is 3 and Y is 0. Okay, so that is how we would partition a line using fractions. Now, how would we partition a line using our ratios? So in this case, we have our same line segment, but the ratios are going to be represented a little bit differently. So in this case, let's say we wanted there to be a 1 to 3. Okay, 1 to 3. When we're working with fractions, the bottom number of our fraction or our denominator tells us how many whole parts there are. When we're working with ratios like this and we want to partition our line segment, we need to add up our 2 numbers, and that is going to get us our total, kind of like the denominator of our fraction. So 1 plus 3 is 4, so that means we need 4 whole part in this segmented line. So just like before, I could create my 4 lines on each one of my whole numbers. Now, where the location of my point is determined by how many segments are on the left side and the right side of my ratio. So my left side has 1, and my right side, let's change up the colors here, my right side has 3. So that means that the location of my line is going to be, or excuse me, the location of my point is going to be located where my ratio of 1 to 3 meet, which in that case is right here at x is located, we're at the 1 mark on the x-axis, and because we're on the x-axis, our y value is 0. So if we were asked, what is the location of a point of the line segment with a ratio of 1 to 3, this would be the location. We have 1 on our left side and 3 on our right side. And if we had to change this into a fraction, right, our point is located here at the kind of like 1 spot, so it would be 1/4 of the way down our line segment. Okay, we can do this. Let's do it just one more time. Let's do another 8ths one. So let's do 5 to 3 as a ratio, 5 to 3. So once again, in order to do this, we need to add our two numbers together to figure out what kind of that denominator is, or how many parts we need on our line segment here. We need 8, so I'm going to draw my original 4, and then I am going to split them in half. Apologize for having to look down here. There we go. Okay, we've got 8 little segments, and our line segment is split into 5 on the left side. 1, 2, 3, 4, 5. And then we've got 3 on the right side. 1, 2, 3. So the location of my point is going to be right here. And if I was asked, what is the location? Well, this is at 1, and this is at 2, and this is at 3, and we're halfway between 2 and 3. So we've got x is 2.5, and y is 0, because we're still working on the x-axis. Okay. Up next, let's talk about how to do this, but with diagonal lines. So I just showed you how you do it with a vertical or a horizontal line. I only showed examples with horizontal lines, but vertical lines are done the exact same way. And in this case, let's look at what we would do if we were working with a diagonal line. So here, I've just got a few steps. So for this example here, the first thing we need to do is identify what is our fraction for our ratio so we know how much to partition our line by. So just like I shared before, when we have the ratio A to B, which in this case is 2 to 1, then we put the first number on top of our fraction, and then we add them the two numbers up, which 2 plus 1 is 3, and so we have 2/3. So we are looking at moving 2/3 of the way up our line. How do we know how far up our line we need to move? First, we need to identify what is the distance traveled in the x and the y directions. So when we're doing this, it's kind of like we're creating a slope triangle. So we want to know how much are we moving in our y and in our x directions here. Okay, so to do that, we can just skip count up. We've got 1, 2, and 3. So 3 is our distance here in our y direction, and then we can go 1, 2, 3, 4, 5, 6. So we have 6 here in our x direction. Now, once we've identified that, then what we want to do is multiply each one of these values times our fraction. So we want to take 3 and we want to multiply it times 2/3. And see how I've written this here? I like to write this with kind of this 3 on top. You could even turn them both into fractions, because when we're multiplying, we multiply straight across, and I want to make sure that I'm not accidentally multiplying maybe the numerator and the denominator together. We're not doing that. We multiply straight across. So I like to either write the 3 so it's level with the numerator, this top number, or I like to write them as fractions. So when we're multiplying, like I said, we multiply straight across. So we do 3 times 2 is 6. And 3 times 1, or 1 times 3 is 3. And so we get the fraction 6/3. We want to make sure that our fraction is simplified to the best of our ability. 6 and 3 both have a 3 in them. So if I divide my 6 by 3, and if I divide my 3 by 3, I get 6 divided by 3 is 2. And 3 divided by 3 is 1. And remember, whenever we have a 1 in our denominator, it's the same thing as just a whole number. So what we have found is that we have the value 2, and this is going to be how much we are increasing our y value at. But before we talk about that, we next need to find how much is our x value changing. So to do that, we need to take our 6 here. I'm going to put it in a fraction form, and we need to multiply it times our 2/3, just like we did before. Remember, when we're multiplying fractions, we multiply straight across. So we have 6 times 2 is 12. 1 times 3 is 3. Once again, both 12 and 3 have 3 in them. So I'm going to divide both values by 3. 12 divided by 3 is 4. 3 divided by 3 is 1. So that means that we are increasing our x value by 4. Okay, so we have what we're going to be increasing our y value and what we're going to be increasing our x value by. So let's talk about what do I mean by this. So in this case here, I am going to pick my leftmost point. Okay, my leftmost point. My leftmost point when I'm reading from left to right is going to be 0, 0, right? If I kind of take a line, and let's take a line here. I'm going to change up this color. So let's take a line. It's whatever point, right? If I'm reading from left to right, currently I'm reading this graph. I'm going from this line to this line to this line, this line. We want the one that is on the left side most. So that is my point 0, 0. Okay. So I'm going to take my point 0, 0, and actually I'm going to erase this so you are able to better see here what I am talking about. My leftmost point, I am going to take that. And I am going to increase my leftmost point by 2 values in my y direction. And I am going to increase it by 4 values in my x direction. Okay, so I've kind of taken this point and mildly translated, right? It's kind of like a translation, up 2 and over 4, going a positive 2 in the y direction and a positive 4 in my x direction. And this is going to get you the location of your point when you have partitioned this line segment in a 2-to-1 ratio. Now, the location of this point, I'm going to go down and find where does it cross my x-axis. It crosses at 4. And where does it cross my y-axis? It crosses at 2. Now, in this example, our line segment starts at 0, 0. So that means that basically whatever my numbers are when I'm calculating here, I'm actually calculating the y value and the x value of my coordinates specifically, but this does not work with all line segments. It only really works when our line segment starts at the point 0, 0. Okay, so keep that in mind. Now, let's look at an example where we are not starting at the point 0, 0. So in this case, we're starting at the point 0, 1, and we want to split this line segment in a ratio of 1 to 3. So just like before, I'm going to have the ratio 1 to 3. I'm going to take the first number, I'm going to put on top of my fraction, and then I'm going to add up my two values, 1 and 3. 1 plus 3 is 4 to get my fraction that I am going to move up my line to or partition my line and to identify where the location of that ratio would be. So just like before, I'm going to draw my triangle to identify how much my x and my y directions are changing. I'm increasing by 1, 2. I'm increasing by a value of 2 in my y direction and 1, 2, 3, 4 in my x direction. Just like before, I'm going to take each one of these values. I'm going to turn them into a fraction, so I make sure that I'm multiplying correctly. And I'm going to multiply each one of them by my fraction that I have created, the 1/4, okay? Because I want to move 1/4 up in my x direction and 1/4 up in my y direction. Multiplication, we multiply straight across, so we have 2 times 1 is 2, and we have 1 times 4 is 4. Both of these values are even, so I can divide them both by 2, and I get 2 divided by 2 is 1, and 4 divided by 2 is 2. So in my y direction, remember this is my y, and this is my x direction. So my y direction, I'm increasing by 1/2. And in my x direction, I have 4 times 1 is 4, and 1 times 4 is 4. And anytime we have the same number on the top and bottom, we get the value 1. And I could divide both of these by 4 and get 1/1, but when we have the same number on top and bottom, we have the value 1. So that means that I am increasing my x value, like in the x direction, I'm increasing by 1 whole unit. I'm going to erase again here so that you can see better what I am doing. Okay, and so in this case here, we are increasing, we have to pick our point first. We have to pick our leftmost point. The leftmost point is the point that is in the most in the left direction, so it's this point 0, 1. And I am going to increase by 1/2 in my y direction and 1 in my x direction. So that means right here, this is the location of my point on my line segment that is 1/4 or a 1:3 ratio up my line segment. Now we need to find the location of that point. So I'm going to go down to my x-axis and see where I cross. I cross at the value 1. And then I'm going to go to the left and see where I cross here. And I'm crossing at 1/2. So the location of this point is located at 1 and 1/2. If I wanted to write the 1 and 1/2 as a fraction, I could also write this as 1 and 3/2 because we have a whole half and then another half added onto it. Either one of these answers works. Make sure you are paying attention to what the question is asking. Does it want it in decimal or does it want it in fraction? All right, guys, that is it for this lesson. Like always, please reach out if you have any questions, and until next time, bye, guys.